This lecture will talk about the rule of idempotence, or idem for short. So idem means, I think in Latin, the same. So you'll see why this is called the rule of idempotence when you see what the rules look like. So we have a version for and we have a version for or. So if you have, the rule of idempotence says if you have the formula P, then you can derive the formula P and P. Or if you have P and P, then you could have just P. So it goes from P to P and P, or it goes from P and P to P. So that's idem and. Again, not that I care about the and part, and one of them, your text labels is idem in and idem elimination. Don't worry about that. And we also have the rule of idem or, which says if you have the formula P, then you could also get the formula P or P. In other words, if you have P, then you could have the formula P or P, and if you had the formula P or P, you can get the formula P. Now, what you may be thinking at this point is, this is the stupidest rule ever. Why do I need this rule? I mean, if you look at the different versions, well, if we have P, then we can derive P and P. Well, no, duh. We can just use and introduction. If we have the formula P and P, we can derive P. Again, no, duh. This is just the rule of and elimination. Likewise, if we have the formula P, we can derive the formula P or P. No, duh. That's just or introduction. And then if we have the formula P or P, we can derive the formula P. Okay, this one we can't do using our existing rules. So, maybe that's useful. The proof of it is actually not hard, to move from P or P to P. It's a little weird, but it's not hard. It's pretty obvious that if P or P is true, then P has to be true. So it's a pretty obvious rule. So what is the utility of it? Well, the utility of it is in the fact that it's a rule of replacement. And that it can be used inside formulas. So if we have the formula P or P arrow Q, and what we don't want all of this extra P in here, we just want to have P arrow Q, well then we can get that by the rule of idem. Because idem works inside of lines. Likewise, if we had P and P arrow Q, we could get P arrow Q by idem. So that's the utility of it. It doesn't have a lot of role to play, but every now and then it's a super useful little rule to have. So that's why we have it in our rule set. Because, so here we can get, so just looking at the rule of P, suppose we have P and P arrow Q, and we want to get to P arrow Q. If we didn't have the rule of idem, we could get this easily enough. We would assume P, try to get to Q, and then get this by arrow in. And we could get to P and P because and in lets us create that using the P. But why go through 4 steps when we could just do 1 for something that is obviously valid? So that's why we have the rule of idem.